When adding floodlights to an existing circuit with an insufficient ground, you must take several steps to ensure safety and compliance with electrical codes. Firstly, you must determine if the new circuit will exceed the ground wire's capacity. Calculate the total amperage of the existing circuit and the new floodlights. If the total amperage exceeds the capacity of the ground wire, you will need to upgrade the entire circuit with a larger ground wire. Secondly, you must connect the new junction boxes to the existing ground wire. If the existing ground wire is open, you must replace it with a new one that meets the required size. Connect the new junction boxes to the ground wire using proper grounding connections such as ground screws or wire nuts. Thirdly, you must install ground fault circuit interrupter, or GFCI, protected receptacles. All ungrounded receptacles on the circuit must be replaced with GFCI protected receptacles. Label these receptacles with no equipment ground to indicate that they do not have a direct connection to the ground. Fourthly, ground the metal weatherproof, or WP, boxes for the floodlights. Metal WP boxes must be grounded to protect against electrical shock. Connect the grounding screw in the WP box to the ground wire using a grounding pigtail or ground screw. The National Electrical Code, or NEC, mandates specific requirements for grounding and bonding to ensure electrical safety. Article 250 covers the general requirements for grounding and bonding of electrical systems. Grounding electrode system requirements can be found in NEC Article 250.50 through 250.60. These sections detail the types of grounding electrodes that are permitted, such as ground rods, metal water pipes, and concrete encased electrodes, as well as the requirements for their installation and connection. Equipment grounding conductor requirements are detailed in NEC Article 250.118 through 250.130. These sections specify the types of conductors that are permitted to be used as equipment grounding conductors, such as wire, cable, and metal raceways, and the methods for connecting them to equipment and enclosures. GFCI protection requirements can be found in NEC Article 210.8. This section specifies where GFCI protection is required for receptacles such as in bathrooms, kitchens, and outdoor locations to protect against electric shock hazards. Bonding requirements are detailed in NEC Article 250.90 through 250.102. These sections cover the requirements for bonding metal parts of electrical systems together to create a low impedance path for fault current, such as bonding metal water pipes, gas pipes, and structural steel. Sizing, grounding, and bonding conductors. Use NEC Table 250.122 to determine the minimum size of equipment grounding conductors for grounding raceway and equipment. This table provides guidance on selecting the appropriate size of grounding conductors based on the rating of the overcurrent protective device in the circuit. For example, if the overcurrent protective device is rated at 20 amps, the minimum size of the copper equipment grounding conductor is 12 American wire gauge, or AUG. If the overcurrent protective device is rated at 30 amps, the minimum size of the copper equipment grounding conductor is 10 AWG. If the overcurrent protective device is rated at 60 amps, the minimum size of the copper equipment grounding conductor is 10 AWG. For circuits exceeding 60 amps, refer to the table for the appropriate grounding conductor size. When dealing with older wiring systems, it is crucial to identify and address potential grounding issues to ensure electrical safety. One common issue is the presence of undersized grounding conductors, which may not be adequate to handle fault currents. In such cases, it is necessary to upgrade the grounding conductor to meet current NEC requirements. Another issue is the absence of grounding conductors in older wiring systems, particularly in older homes. In these situations, it may be necessary to install new grounding conductors or utilize GFCI protection to mitigate the risk of electric shock. Additionally, it is important to inspect and test existing grounding connections to ensure that they are intact and provide a low impedance path for fault current. Loose or corroded grounding connections can compromise the effectiveness of the grounding system and increase the risk of electrical hazards. When extending existing circuits, It is essential to ensure that the new wiring is compatible with the existing wiring and that all connections are made properly. Use appropriately sized conductors and connectors that are rated for the intended application. Follow NEC guidelines for splicing and terminating conductors to ensure reliable and safe connections. When working with metal enclosures, such as weatherproof boxes for floodlights, it is important to properly ground the enclosure to protect against electric shock. Connect the grounding conductor to the metal enclosure using a grounding screw or other approved grounding method. Ensure that the grounding connection is secure and provides a low impedance path for fault current. GFCI protection is a critical safety measure for circuits that serve outdoor locations or areas where moisture is present. GFCI devices monitor the current flowing in a circuit and detect any imbalance that may indicate a ground fault. When a ground fault is detected, the GFCI device quickly interrupts the circuit to prevent electric shock. Install GFCI protection for all receptacles and equipment located in outdoor areas, bathrooms, kitchens, and other locations where there is a risk of exposure to moisture. Label all GFCI protected receptacles with the no equipment ground to inform users that the receptacle does not have a direct connection to the ground. This labeling helps prevent confusion and ensures that users are aware of the limitations of the grounding system. Before undertaking any electrical work, it is essential to disconnect the power to the circuit at the breaker panel. Verify that the power is off using a voltage tester before proceeding with any wiring or connections. Follow lockout/tagout procedures to prevent accidental re-energization of the circuit while work is in progress. Use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools when working with electrical circuits. Avoid working in wet or damp conditions, as this increases the risk of electric shock. Work with a qualified electrician is always recommended. Working with electrical systems can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely. If you are not comfortable working with electricity, consult with a licensed electrician to ensure that the work is done properly and in accordance with all applicable codes and regulations. A licensed electrician can assess the existing electrical system, identify any potential hazards, and recommend the appropriate solutions to ensure electrical safety. They can also perform the necessary wiring and connections to add floodlights to an existing circuit in a safe and compliant manner. Consider the type of floodlights you plan to install, and select fixtures that are suitable for outdoor use and rated for wet locations. Ensure that the floodlights are compatible with the voltage and amperage of the existing circuit. When installing floodlights, follow the manufacturer's instructions and NEC guidelines for mounting height, spacing, and aiming. Properly position the floodlights to provide adequate illumination without causing glare or light pollution. Inspect the wiring and connections regularly to ensure that they are in good condition and free from damage. Replace any damaged or worn wiring immediately to prevent electrical hazards. Test GFCI devices periodically to ensure that they are functioning properly. Press the test button on the GFCI device to simulate a ground fault and verify that the device trips and interrupts the circuit. If the GFCI device fails to trip, replace it immediately. Remember that electrical codes and regulations vary depending on the location, so it is important to consult with local authorities to ensure compliance. Obtain any necessary permits before starting any electrical work. Keep accurate records of all electrical work performed, including wiring diagrams, circuit layouts, and equipment specifications. This documentation can be helpful for future maintenance and troubleshooting. Educate yourself about electrical safety and learn how to recognize and respond to electrical hazards. Take a first aid course to learn how to provide assistance to someone who has been injured by electricity. By following these guidelines, you can safely add floodlights to an existing circuit with an insufficient ground and protect yourself and others from electrical hazards. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Consider the environmental impact of your lighting choices and select energy-efficient floodlights that minimize energy consumption and reduce your carbon footprint. LED floodlights are a popular choice due to their long lifespan, low energy consumption, and high light output. Look for floodlights that are Energy Star certified to ensure that they meet strict energy efficiency standards. Install timers or motion sensors to control the floodlights and reduce energy waste. Timers can be programmed to turn the floodlights on and off at specific times of the day, while motion sensors can detect movement and turn the floodlights on only when needed. Properly dispose of old light bulbs and electrical equipment to prevent environmental pollution. Many retailers offer recycling programs for fluorescent and LED light bulbs, as well as electronic waste recycling events for old appliances and equipment. Be aware of the potential for electromagnetic interference, or EMI, from electrical devices and wiring. EMI can disrupt the operation of sensitive electronic equipment, such as audio and video systems, and can also cause interference with wireless communications signals. Use shielded cables and grounding techniques to minimize EMI and ensure proper operation of electronic equipment. Consider the aesthetics of your lighting installation and select floodlights that complement the style and design of your home or building. Choose fixtures with appropriate finishes and mounting options to create a cohesive and visually appealing lighting scheme. Be mindful of the impact of your lighting on neighboring properties and avoid causing excessive glare or light trespass. Aim the floodlights carefully to direct the light where it is needed without shining into windows or creating unwanted light pollution. Work with a qualified lighting designer to create a custom lighting plan that meets your specific needs and preferences. A lighting designer can help you select the right fixtures, placement, and controls to achieve the desired lighting effects while minimizing energy consumption and light pollution. Stay up to date on the latest advances in lighting technology and consider upgrading to newer, more efficient lighting systems as they become available. New lighting technologies, such as smart lighting systems and solid-state lighting, offer improved performance, energy efficiency, and control capabilities. Follow best practices for electrical safety and maintenance to ensure the long-term reliability and safety of your lighting system. Regularly inspect the wiring, connections, and fixtures for any signs of damage or wear, and address any issues promptly to prevent electrical hazards. Remember that electrical work can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. Always disconnect the power before working on electrical circuits, use appropriate personal protective equipment, and follow all applicable codes and regulations. By following these guidelines, you can safely add floodlights to an existing circuit with an insufficient ground and create a safe, efficient, and aesthetically pleasing lighting system for your home or building. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Understanding the grounding system in an electrical circuit is critical for safety. The grounding system provides a low impedance path for fault current to flow back to the source, which helps to quickly trip the circuit breaker or fuse and prevent electrical shock. In a properly grounded circuit, the metal enclosures of electrical equipment, such as appliances and lighting fixtures, are connected to the grounding system. This ensures that if a fault occurs and the metal enclosure becomes energized, the fault current will flow through the grounding system and trip the circuit breaker or fuse. Without a proper grounding system, a fault in the electrical system can cause the metal enclosures of equipment to become energized, creating a dangerous shock hazard. If someone comes into contact with the energized enclosure, they could receive a severe electrical shock. That is why it is essential to ensure that all electrical circuits are properly grounded and that the grounding system is maintained in good condition. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults and quickly interrupt the circuit to prevent electrical shock. A GFCI device monitors the current flowing in the circuit and detects any imbalance between the hot and neutral conductors. If a ground fault occurs and some of the current starts flowing through a path other than the intended circuit, the GFCI device will detect the imbalance and quickly trip the circuit. GFCI protection is required in many locations, such as bathrooms, kitchens, outdoor areas, and construction sites, where there is a risk of exposure to moisture or other conductive materials. GFCI devices can be installed as receptacles or as circuit breakers in the electrical panel. They provide an important layer of protection against electrical shock and can save lives. Electrical codes and regulations are in place to ensure the safety of electrical systems and to prevent electrical hazards. These codes and regulations specify the requirements for wiring, grounding, overcurrent protection, and other aspects of electrical systems. It is essential to comply with all applicable codes and regulations when installing or modifying electrical systems. Failure to comply with electrical codes can result in fines, penalties, and, more importantly, increased risk of electrical hazards. Local electrical inspectors are responsible for enforcing electrical codes and regulations and can provide guidance on how to comply with these requirements. When working with electrical systems, it is important to use appropriate tools and equipment that are designed for the task. Use insulated tools to protect yourself from electrical shock. Wear safety glasses to protect your eyes from flying debris. Use a voltage tester to verify that the power is off before working on any electrical circuit. Use a wire stripper to remove insulation from wires without damaging the conductors. Use a crimping tool to make secure and reliable connections. Using the right tools and equipment can help you perform electrical work safely and efficiently.